So here in problem number 1, we're going to build on some of what you already know, which is that if we ever come up with a problem like this, where we've got 16 to the 3x equals 8, and we want to isolate x and figure out what x is, then what we're going to do is we're going to change the bases. So we can take 16 and 8, and we can take them all the way down to a base of 2. If we do that, we can rewrite 16 as 2 to the 4th. Don't forget about that 3x. That's got to remain in that as part of that exponent. 8 is going to be rewritten as 2 to the 3rd. So what you can see here is now we've got the same base for each side. That means that we can eliminate the bases and we can just work with the exponents. So we get 4 times 3x equals 3. So this gives us 12x equals 3 divided by 12. X equals 3/12, which is the same thing as saying 1/4. So if we want to know how to get from 16 to the 3x down to 8, we would have to make x 1/4. Okay, in problem number 2, we're not going to be able to use the same method that we used in problem number 1. The reason why is because with 15 and 285, we can't get down to the same base. So we're going to learn a new method of solving a problem in which it doesn't look like you can get to it. What we're going to do is we're going to take the common log of both sides. So we're going to go log of 15 to the 3x equals the log of 285. So now go back to our rules for properties of logarithms. What we can do is we can take this 3x right here and we can move it down in front of the log. So we're going to get 3x log 15 equals log 285. Now, what is being done to the x by the 3? It's being multiplied. What is the log of 15 doing to the x? It's again multiplying. So how do we get rid of multiplication? We do division. So the way that we're going to get rid of it is we're going to divide by 3 log 15. Because remember, when you're doing multiplication and addition, it doesn't matter what order you do them in. If you can multiply them in any order, then that means that they can both be taken out at the same time. So if we divide one side by 3 log of 15, we're going to divide the other side by 3 log of 15. So x is equal to log 285 over 3 log 15. Now, if you don't have a calculator, this answer is going to be your final answer. If you do have a calculator, then what you're going to end up with is approximately 0.6958. Again, there's no way you're going to get to this without a calculator. So if you have a calculator, this is your answer. I'm sorry, if you don't have a calculator, this is your answer. If you do have a calculator, this is going to be your answer. And make sure you put it as an approximation because it's definitely not going to be on the dot. For problem number 5, we're going to find the solution of log of 4x minus 3 equals 2. So remember that anytime that we have a log with no base, we know that base is assumed to be 10. So once we've got this, we now have a base, we have an x, and we have a y. So we can take it and transform it into exponential form. So we're going to get 10 to the second equals 4x minus 3. 10 to the second is 100. And now it's just a matter of isolating x. So add 3 to both sides. You're going to get 103 equals 4x. And then divide by 4, and you're going to get x is equal to 103 over 4, or 25.75. For problem number 6, we're going to again use properties of logarithms to solve a logarithmic equation. So we've got log of x minus 3 plus log of x equals 1. Now both of our logs are common logs, so we've got bases of 10. So that tells us we can take these 2 logs and we can put them together. So we're going to get log of x minus 3 times x, because if we're adding logs together, we can multiply whatever's in this position. And that's going to be equal to 1. So then go ahead and work out that multiplication. So log of x squared minus 3x equals 1. Now that we've got it down to a single log that's equal to a number, we can now go ahead and transform our logarithm into exponential form. So we've got a base of 10, y is 1, and that's equal to x squared minus 3x. So again, this is going to be 10 equals x squared minus 3x. And you can see that we've got a quadratic with an ax squared, a bx, and a c. So we're going to take this c and move it over to the other side. It's going to leave us with 0 equals x squared minus 3x minus 10. Now we ask ourselves, what are the factors of 10 that subtract to negative 3? So we get 0 equals x minus 5 and x plus 2. So that tells us that x is equal to 5 and negative 2. Now we just need to go back and check and make sure that our two answers are correct. So I'm going to put 5 in for x here and 5 in for x there. So 5 minus 3 is 2, and you get 5. 2 times 5 is 10, so log of 10 equals 1. So that's 10 to the first equals 10, so that would be correct. So we know that 5 is a solution. Now we put negative 2 in here. Negative 2 minus 3 gives us negative 5. As soon as we see that negative 5 in where the x would be, you know that that cannot be a solution. So we're going to take negative 2 out.